Hi, folks. Thanks for joining us today. We're going to give people just another minute to sign on, so please be ready. We're going to be talking about natural language processing exposed, the art, the science, and the application. So hang on for just 1 minute while people sign in, and we'll get going. Thanks. Just a few more seconds till we get started. All right, I think that's where we're going to go. Good morning, good afternoon, good evening. We have people from all over the world, so depending on where you are, one of those is for you. Thanks for participating in our webinar today, Natural Language Processing Exposed, the Art, the Science, and the Applications, with Dr. Sid Reddy. I know you're dying to dive in, but first let's just go over a few housekeeping items really quickly. First, please note there is no separate dial-in number for the webinar, so if you have any difficulties with audio, please try refreshing your browser because all the audio is on the computer. Also, if you have a question at any time during the webinar, please use the Ask a Question tab. It's located on the left-hand side below the player. Your question will be addressed during the Q&A session at the end of the presentation, and if your question isn't addressed, then a team member will follow up with you later. There are additional resources for you to check out under Attachments to the right of the Ask a Question tab. You can download anything that's there, and please note that any of the links in the presentation are not live, but they can be found there, or you can just make a note of them. At the end of the webinar, please take a moment to rate this presentation and provide feedback using the Rate This tab on the right-hand side below the player. And seriously, please do that. It really helps us know what was valuable and how we can improve, so please do. Finally, the recorded version of this presentation will be available using the same URL you used to attend shortly following the conclusion. So feel free to share it with your friends and your colleagues, and if you forget the URL, don't worry, you'll be sent the webinar recording within a few days afterwards. Enough with the housekeeping, now we'll dive in. My name's Gary Gerber. I'm Head of Product Marketing at Conversica, and it's my pleasure to introduce our esteemed guest, Dr. Sid J. Reddy. Dr. Reddy is a recognized expert in natural language processing and computational linguistics. He's designed, developed, and contributed to dozens of NLP systems used in production in a wide array of use cases and industry verticals. His interest in NLP has allowed him to develop text mining infrastructures from scratch at 2 technology startups and at the Mayo Clinic, as well as Northwestern University, where he founded their NLP lab. And most recently, Dr. Reddy served at Microsoft as Principal Applied Scientist. He's a patented inventor, sought-after industry speaker, and published author with research featured in over 50 peer-reviewed publications and technical conferences. And with that, it's my pleasure to introduce to you Dr. Sid J. Reddy. Sid, you there?
Yes. Thanks all for joining the webinar. We're going to talk about natural language processing and how it is applicable for conversational AI, which is the most advanced application for natural language processing, and also discuss some of the components and some of the smaller applications of it. Before we dive deeper, we would request you to take a small poll.
So thanks, Sid. So we're going to be doing a poll really quickly. We want to see where you folks are coming from. Our first poll will be, let me grab the poll. There it is. Question, where is your organization in applying AI to help the business? A, not interested at all. B, exploring but not using it. C, using it to analyze and advise, things like lead scoring and such. D, using it to actually help the humans execute, kind of like helping the salespeople engage. Or E, you've deployed AI to fully act autonomously on behalf of your company. Here comes the poll. We'll give everyone just a minute to respond. Please vote. Vote early, vote often. I don't see any votes coming in. Is there a reason for that? Here we go. right, we'll give just another few seconds while people figure out where the buttons are. I get that. Okay, so it looks like we have a bit of a mix. Some people feel that they've actually deployed it quite fully autonomously, which is interesting. And then a few people are kind of exploring it, and everyone else is all over the map. So interesting, Dr. Sid. It looks like we're seeing a bit of a dichotomy, people who are just beginning to explore and people who are doing it quite seriously, but not a lot in between. What do you make of that?
Yeah, it's an interesting audience. I would think it's certainly possible to explain some of the basics and also showcase some of the more complex applications, so we will be able to benefit everyone. So just a brief history of conversational AI and how it relates to information technology. The way I see conversational AI is it's the final phase of information revolution. You have Usenet, which in the early days of internet, to locally store documents that are shared by different people. And then with World Wide Web having so much information and you want to track which categories they belong to, we have search directories such as by Yahoo. And then we have some basic search engines for doing information retrieval. You don't have to remember what categories there are because you can't capture the entire web into 8 or 9 categories. You just type a simple search, a simple word, and you get all the relevant documents, and that's information retrieval, which is a topic within natural language processing. And more advanced natural language processing is applied in today's search engines that are widely used. They're not just information retrieval, but also information extraction. That is, in addition to just giving you the relevant documents to a question, you also get, if you type in a hotel, you would get the address of the hotel, you would get the reviews, and you would also probably get even the menu in some search engines. So that is advanced information extraction. So these advances in information extraction and information retrieval really allowed us to create conversational AI. Conversational AI allows people to type in their requests or type in a message as if they're talking to a human, and just like a human would answer your questions, the assistant answers questions, and you don't have to repeat all the information. Like in search, you have to retype the query from the beginning, or you have to use some filtering, you have to click some buttons. But instead of all that, you just need to refine your message with an additional attribute, or in the case of Conversica, we have a multi-turn conversational AI system where our users and the assistant keeps talking over multiple turns. It's not just like they ask something and you get it, but you can keep conversing until an objective is reached. So conversational AI is like the final frontier of both information technology and also data science and natural language processing in general. So what is it made of? You hear different terms. NLP stands for natural language processing, text mining, computational linguistics, machine learning on text data, deep learning approaches for text data, NLU, natural language understanding, and NLG, which stands for natural language generation. So since about 50% of the people are either exploring AI and not using it, or using AI for analyzing and advising, so that's together at 75%. So I would spend some more time explaining some of the basics of NLP, text mining, machine learning, and deep learning. NLP, which stands for natural language processing, is basically you're teaching a computer how to read text. And in other words, it's the way to do text mining. So there is a lot of hidden information in text. Just like you would mine gold from earth, you would mine information from text. And the way to do that is you process the documents and you split them into sentences. you process the sentences and split them into words. And in each word you tokenize and you do stemming and lemmatization, which is normalization of the words. And for each sentence, you would also understand the grammatical nature of it by doing part-of-speech tagging, phrase chunking, such as you would know which is a verb phrase, which is a noun phrase, which is a prepositional phrase. And then you would build a complete parts tree, and you would also simplify the sentences into simpler phrases and clauses. At a meaning level, you would process the sentences into their semantic equivalents using word vectors, distributional semantics, and dictionaries. And at a context level, you would use section detectors and coreference resolution to find the anaphoras that need to be resolved. So if someone says he or she, you need to understand what that he or she refers to. All of this is natural language processing. And many people said NLP is a hard problem, but I'll also try to explain why it is a hard problem. Firstly, there isn't one language. There are tens and thousands of languages, and there are ever-growing number of words in each language. There are hundreds and thousands of words per language in the major languages that we know. And for each language, the syntax is very complex. There are varying number of words per sentence with varying amount of perplexity. There are different number of relative clauses and prepositional phrases across a sentence. And it's not just the syntax. Even if the syntax is very clear, there are also semantic ambiguities. So there is polysemy, which is the same word can mean different things in different contexts. There is synonymy, which is the same, which is different terms would mean the same thing in particular context. And there are partial words, abbreviations, and certain specialized names that are not known to people outside a given domain. In addition to all these ambiguities and complex syntax and just the volume, the language is always, any language is constantly changing and evolving. Words like grill and Google were initially a noun, but now they're also used as a verb. So it is very confusing for a parser to know whether something is a noun or a verb. It has to identify that based on the context. So given all this complexity, it's important to understand the different approaches used to process the natural language. So there are three prominent approaches. One is rule-based approach. Rule-based approaches are very good for high precision and low recall, which is when you know that certain things fit certain rules, you know exactly what to do. But it is impossible to specify all the rules that are applicable. And this means that you need also regular maintenance. So what used to be a noun is now a verb, so you need to update your grammar to reflect that. And the task also evolves. So if there are new examples, and so you need to also write new rules to accommodate them. So there are different ways to do that. There are regular expressions, there are dictionary lookups, there are if this then that, and then I'm also going to shortly introduce an approach called computational linguistics, which is rule-based approaches with some knowledge of linguistics. And then there are traditional machine learning approaches, which are good for both precision and recall, but they have a limit. And they may need also rule-based pre-processing and post-processing for handling exceptional cases. So essentially you give some data and it performs very well up to a limit. Some of the examples are support vector machines for instance classification, hidden Markov models for sequence classification, and k-means for clustering. And more prominently these days is deep learning. It's becoming more and more applicable because of their robustness and flexibility. The only caveat is they typically need more data than traditional machine learning, but it's very good for classification, like using convolutional neural networks for instance classification, long short-term memory networks for sequence classification, and autoencoders for clustering kind of problems. So these are the different ways to do NLP. I was just talking about rule-based approach, and those rules have to be written from an understanding of what that language or what that discourse element or what that particular span of text means. And that means you have to study the language, and that is called linguistics. You study the language either at a structural level or at a functional level or at a generative level or at a cognitive level. And when you do that study and program it, or in a way apply algorithms, databases, machine learning, artificial intelligence, and graph theory on it, it becomes computational linguistics. But prominently it's done. It's used to improve rule-based approaches, but it's also used as features for machine learning approaches. So machine learning approaches are primarily unsupervised, supervised, or semi-supervised. Unsupervised, just like k-means and autoencoders, are you don't have any annotations, you only have unlabeled data, and the algorithm uncovers hidden regularities or detects any anomalies in the data. There is no cost to this because you don't need any human labels, but the accuracy could also be low because the system is just guessing that these are the clusters as opposed to knowing what the clusters are. And then there are supervised algorithms which predict the label of an unsealed example based on the labels of the scene. So you need some label data, which means that there is a high cost, but accuracy is better than unsupervised because you have some examples and you have an idea of what classes to look for. These are very prominent. And then there are also semi-supervised algorithms, which is a marriage of both supervised and unsupervised. They use the examples that are provided with labels and to know what needs to be classified, what are the classes involved, and get some sample examples, but they learn a lot of domain knowledge from unlabeled data. So the benefit of this is you typically need lesser number of annotations, like you see in transfer learning, because you have this unlabeled data. But on the other hand, you also need, the algorithms are also more complex, and it may or may not always lead to decrease in cost. More often than not, it would lead to increasing in accuracy. So we are hearing deep learning. What is deep learning? Deep learning is really, you can think of it as a more advanced machine learning. If you are able to build machine learning, so you can think of it as, deep learning as multiple nodes of machine learning stacked into layers, and those nodes are all interconnected to each other. So what's the peculiar feature about deep learning and why it became famous is deep learning basically allows you to capture any arbitrary function between a set of input variables and an output variable or a set of output variables. So whether it is instance classification where there is just one label with some classes you're trying to predict, or sequence classification like in part of speech tagging where there is a sequence and for each element in the sequence you're trying to predict the corresponding part of speech tag, for example, label, or it can be clustering. So the basic idea is, because of this non-linear activation functions that are connecting these individual linear classifiers, you're able to build, you're able to construct a model for any complex relationship. So if you remember when the slide where I described NLP is hard, they share similar relationships both in the amount of complexity and also the volume. There are tens of thousands of languages, hundreds and thousands of words. The syntax and semantics and pragmatics are not fixed, they're evolving, and there's a lot of ambiguity. So all this complexity can't be captured using linear classifiers like SVM or random forests or naive Bayes or hidden Markov models or conditional random fields. So deep learning became a very good friend for natural language processing, if you want me to put it that way. So these are some of the tools we use within natural language processing, and the more advanced tools you use, the more you can understand natural language. When you are able to do natural language processing so well and so accurately that you can say that the system understands all the key information such as intents and entities, you can then say that you're doing natural language understanding as opposed to just natural language processing. So NLU and NLG are like the critical pieces within conversational AI. Conversational AI typically involves turning raw big data to knowledge. We have information retrieval to retrieve relevant documents, and then we have information extraction to represent the knowledge in structured format. And secondly, you also need to understand what is being said by the users, whether it is a query or whether it is a question that is asked by a question answering system, or it's a simple message that you see in conversational AI. You would again use information extraction, and then you also classify the text to identify the intents. And finally, you also do natural language generation, which is summarization, question answering, and other advanced algorithms. So as we discussed, information retrieval is poor man's NLP. It's in the evolution of information technology, information retrieval came first and then came information extraction. So let's focus a bit on information retrieval. Information retrieval takes as input large collections of unstructured data with query terms such as keywords, or for question answering and conversational AI applications, you have a natural language message or a query or a question. And then as output, you typically list results, in this case it's documents, in the order of how relevant they are to a given search, or if you know the precise answer to that question, such as in question answering and conversational AI, you just give that out. It is evaluated using precision, recall, and F1 score. Very briefly, since a lot of people are new to AI, precision is of all the things that the system says are correct, how many are really correct. Recall is of all the things that are actually correct, how many the system identified as correct. And F1 score is kind of an average of both. It's a harmonic mean. Let's not get into the details of why F1 score versus just an average of those, but to summarize, F1 score basically gravitates towards the lower of precision and recall. So that way, if you have a system that's 100% precise but 0% recall, in that it never outputs anything, you don't have a accuracy of 50%, but you have an accuracy of 0% because it doesn't output anything. There are different approaches for this. There is a Boolean approach, there is vector space model approach, and there is probabilistic approach. This is one of the examples where you use relevance feedback, which is you take into account what annotations are being done by humans, and then you decide on the next, you decide how to handle the next quiz based on what are clicked or what are annotated by the humans. And then there is also how you understand the terms. So you can understand the terms just using their raw vector representation where each word is one dimension, or you can represent them as you can represent them in a reduced dimensional space where words that are related to each other mean similar things. So there are different ways of building semantic vectors, but essentially it could be either a first order relationship or second order relationship. A first order relationship are things that appear, or words or terms that appear in the same document. It's like President and Obama, sales and CRM, Pearson and education, and Chrysler and car. Whereas a second order relationship uses the fact that they appear in the same context, such as President Trump and President Obama appear in the same context. So Trump, that is, they appear very close to the word president, for example. So Trump and Obama are related. Similarly, sales and marketing, Pierce and Kaplan are related because they appear in the context of education. So paradigmatic relationships are more useful for information extraction, and syntagmatic models are primarily limited in their use for information retrieval. So getting into information extraction is extracting entities within a sentence and the associations between them. There are different subtasks within information extraction. You have named entity recognition, which is extracting slots or entities from text. You have normalization. Once you have the entities extracted, you then normalize them into a canonical entity name. For example, if there is a company called Conversica and it's also called Conversica.ai, how do you get the company name from text is NER, and how do you normalize them to Conversica is normalization. And you can use dictionary approaches or graph approaches or clustering approaches. And you have coreference resolution, which is resolving the pronouns or anaphora such as he, she, that person to an actual person or whichever concept is involved. And then there is association extraction, which is entities and I mean you perform NER and you perform normalization, but you want to understand how those entities are related to each other. And you have negation detection, which is Conversica is the best company in the world. There is no negation in there. Conversica is not in Alabama. There is a negation there. You can't just assume that Conversica and Alabama are located in the same sentence and assume that Conversica is in Alabama. You have to know that that sentence is negated. And there is de-identification, which is very prominent now, and there is sentence classification, which is intent extraction and intent extraction and language comprehension. So if you do sentence classification well, you can also extract intents and also understand languages. So it's about 30 minutes now. If you have any questions, feel free to leave them in the feedback or questions from audience. If there are more questions, I will answer them towards the end. But within information extraction, there are some prominent algorithms for NER. I just showed an example which uses conditional random fields and vector space models to detect slots within input sentences given some training corpus. And you also have sentence simplification. So sentence simplification essentially referring to the code by Einstein, which is as simple as possible but no simpler, is used to get meaning out of the syntactic jungle. We discussed how natural language sentences could be complex. So there could be relative clauses, there could be coordination, and there could be cause conditionals. Sentence simplification is used to reverse the process in which sub or simpler sentences are created together. So there could be forms of complexity where you have an existing structure and you add some additional information through relative clauses. So you find where there are relative clauses and define them. And then you have coordination, which can happen at a phrase level or at a clause level. Conversica is in Seattle and it is headquartered all in Foster City. Those are two clauses and you can break them. So essentially they're different from each other at a clause level. The other example of coordination is at a phrase level is Conversica is a leader in machine learning and natural language processing. There the coordinated phrases are natural language processing and machine learning. So you would break it into two simpler sentences. Conversica is a leader in machine learning, and Conversica is a leader in natural language processing. And then there are also cause conditionals which enhance the environment. So, so these are different ways in which sentences are made more complex. So you basically reverse engineer the process to create simpler sentences and then use them within information extraction to make the NER and to make the association extraction more accurate. So, so here is an example of coreference resolution, an example architecture where we used rule-based approaches to find anaphoras and pronouns and what named entities they are referring to. And then there is association extraction. As an example, it illustrates how natural language processing, which works at document level and at a word level, it's also called morphological level, and at a syntax level, or it's also called grammatical level, or at semantic or meaning level, or at pragmatic or context level. All these different levels of understanding natural language contribute to features, and these features could be used as an example system into a machine learning system to extract the final tasks. So I want to give more concrete examples from what we learned at Conversica, but let me answer a couple of questions. A sequence of steps as listed by you in the information extraction is a good guideline. Does an NLP algorithm have to undergo all these steps before implementing? It is not necessary to undergo all the steps, but the more you understand the text, the richer is your NLP system. So if you can build a sentiment analysis system, for example, without understanding what they are talking about. It can just say whether the sentiment is positive or negative. But it's very limited in its use, because a negation of a negative entity is a positive thing. So you don't know whether an association being present is positive or negative. For example, HIV is no longer a problem in this world. So it seems like if you would pass this to a sentiment analyzer, it might say that the sentiment is negative, but the sentiment is actually positive because it's talking about a problem that no longer exists. But to answer the question, it is possible to have some of these things as standalone applications, but for a more advanced application like conversational AI, you need to go into a very deep level for information extraction. The other question, one other question I have is how many NLP applications are out there, and how does Conversica compare to what Watson does? So there are a lot of NLP applications. So NLP basically is understanding text and doing something about it. So in whichever business or consumer application you have text, you also have NLP. I'm going to give some examples, example industries that Conversica is working on. And to the Watson question, I played with Watson when I was a faculty at Northwestern. Watson is good as a generic tool that performs relatively well across a broad area of text, but not necessarily very well on specific kinds of text. That was my impression. Whereas at Conversica, we have very accurate information extraction algorithms as an example for the kind of text that we are working with. We're trying to be a leader in conversational AI for business. So in the texts that are about business conversations, Conversica is superior to Watson, but overall, for example, Conversica does not process medical documents, but Watson does. Conversica doesn't process Wikipedia, but Watson does. So in a way, it's not an apple-to-apple comparison, but at the same time, you can't just use Watson for everything. If you have to build a conversational AI for business conversations, Conversica is much superior to Watson. I hope that answers the question. So that brings us to questions related to to some of the examples based on what we did at Conversica. So the previous question was how many NLP applications are out there. So as you can see, we have a wide range of applications or industries that we use Conversica for, and really we have been discussing the hard points and the science behind conversational AI, but in the end you need to find a practical application for this. You need to solve business problems. At Conversica, we have been applying conversational AI for like 10 years to solve real business problems in all these verticals, ranging from technology, finance and mortgage, education, insurance, real estate, etc. There are more questions coming, but I'll stop at a logical pause and answer those questions. But please keep posting the questions. So the first problem we started addressing at conversational AI is the timeless marketing sales alignment problem. What we observed is that businesses spend a ton of resources collecting leads for sales, but as research shows, almost like 4 out of 10 of those leads are never contacted. They're completely ignored. It's a huge waste of resources and opportunities, and until now there's been no way to cost effectively solve it. But we proved that conversational AI is a solution to this Achilles heel. And the way we did that is to create an AI-powered sales assistant. Unlike human assistants, artificial intelligence assistants can reach out to every single one of the leads that you acquired through your marketing, and those leads can engage each one in a human conversation. So one thing that we learned from talking to analyzing the conversations between the artificial intelligence assistant and the human leads is the people feel like they're really conversing with a nice, helpful human who is trying to help them, to get what they need. And in addition, unlike a human who is limited in time, she loves chasing down leads and doesn't have a bad day or has a sick leave or anything. So that's like a very exemplary application of natural language processing, and I want to go a bit deeper and explain our architecture. So when I'm sorry, it keeps taking me to this poll. Gary, do you want to just introduce the poll? I'll go back.
Yeah, it's okay. Let's do the poll really quickly then, since we have this anyway. Folks, so we're going to do our second poll. The question, of course, is, since Sid has been talking about organizations using AI to take care of their leads, and I guess the question here is, how are organizations doing in following up on their leads, right? So A, you're maximizing the ROI from your sales leads, and B, you're doing a good job. C, not bad, not great. D, we know that there's a lot of opportunities we're losing or missing on, or F, we just really need to get our act together. So we're going to open that poll, and we'll spend just a moment. Let people go ahead and start voting. seeing any entries there. Hopefully the system is just being slow. There we go. Okay, it looks like we're not getting a lot of votes here. Perhaps the audience at hand aren't people who are really dealing with sales leads too extensively, but it looks like we have a mix between organizations are doing fair. Everybody's kind of down on the lower end. They're doing fair. They knew there's a lot of opportunities they're missing, and they need to get their act together. So we're going to stop the voting, but I think what we see there is people recognize there's a lot of opportunity for improvement. And I think given this audience is interested in AI, Sid, I think you'll agree that we can all explore that AI might really be the way to solve this and other problems.
Absolutely. So this is the slide I wanted to present, and it always advances in a minute, but what it was showing is how we have more than 30 CRMs or customer relation management tools. The reason why this is important is we need a source for talking to the world. So there is a lot of information out there, and when certain things are registered within the CRMs, like say a client downloads a white paper, our natural language generation system creates a response such as, "Hey Bill, thank you for downloading a paper on sales effectiveness. I wanted to reach out to you and see if there are any questions or we could answer you. Would you like to set up a call?" This is an email sent by an AI assistant using our natural language generation system. And when the lead responds, they can respond by SMS or email, or they can respond in English or French or other languages. But say if the lead responds in English or email saying, "Hey Rachel, can we talk in person tomorrow? I'm busy today reviewing contracts for my team and want to give the undivided attention to you." So this is a natural language response, and this is handled by our natural language understanding engine. Like we discussed, we do intent extraction or intent classification using instance classification algorithms such as SVM, random forest, convolutional neural networks, and we also do entity extraction using conditional random fields, bidirectional LSTMs, etc. So basically a lot of computational linguistics, machine learning, and deep learning algorithms to understand what intents and entities are present in the sentences, or in this case it's actually whole emails. So once we get those intents and entities, we infer what needs to be done. There is intents and entities, and then you get actions. And based on what actions are inferred, the natural language generation system dynamically generates the next level of message, which is, "Hi Bill, Jim is working on this and would like to call you. What would be the best number to call you on during the day? Have a good afternoon." So this is a natural language generation message because the lead says they want to talk in person tomorrow. So Rachel, which is our sales assistant, found someone who is available tomorrow, called Jim, and Rachel is asking what's the best number for them to call because the lead says they're available to talk in person tomorrow. And the lead also says he's busy today, so we don't want to venture and try to call them today. In response to that, the lead says the lead gives the phone number, and at that point there is a handoff because the assistant has everything that's needed to pass to let the human sales rep take care of this, because that's what the lead wanted. And after the hands-off, if after some time there is no update in the CRM, the AI assistant again goes back and says, "Hey, I just wanted to follow up and make sure Jim got all the information you needed. Did you connect with Jim? Thanks and have an awesome day." And then the lead says something, and on and on. So the basic point is this is not like a single turn or like a single classification task. It's a multi-turn conversation over multiple channels and multiple languages. To do that, our integrations with CRMs and our highly accurate natural language understanding engine and our inference engine and our natural language generation system really helped us. What we found was that this AI-driven approach is significantly better, and it sets 30% more appointments than human teams alone. This is for the sales assistant, which is the first problem we're trying to solve. The main reason is most human sales reps, when they contact the leads, they stop connecting after 2-3 contact attempts, whereas Rachel, or whatever you want to name the sales assistant, contacts multiple times as needed, as many times as needed, and so it's able to perform well. And as we are doing this, as we're building natural language understanding and natural language processing and natural language generation, we found that there are these 4 prominent ways that really helped. And this was something that I introduced towards the beginning. Deep learning is the best match for natural language understanding, and fortunately, because we have thousands of customers and millions of annotated and unannotated data, we're able to use deep learning very well. But before during our initial days, we had to use traditional machine learning when we had limited amount of data. That's what companies would do if they're just starting on solving this problem, and they have some human resources for annotation. But if you don't even have human resources, then you would basically use rule-based approaches or computational linguistic approaches. We also, having experimented all this, although we use deep learning prominently, we also have ensemble approaches in our platform that uses a combination of all these. So this is in terms of the natural language understanding, but overall, in terms of the conversational AI itself, as we discussed before, there is this aspect of turning raw big data to knowledge, like from CRM to understanding what they said in the CRM, and then understanding natural language inputs, which is the responses such as emails that you saw was sent by Bill to Rachel, our assistant. So understand what they really mean, understand the intents and entities, and then you do natural language generation to correspond with Bill and connect him to Jim. So another way to put the same thing is there are 4 intelligences needed for conversational AI. One is natural language understanding, there is inference engine, and then there is natural language generation, and finally you have human intelligence also to do some annotations that are missed by the system, and the more human effort we have, the better. So one thing that we've learned that applies particularly to sales assistants is the 4 P's. If we want to maximize the responses from leads and have a better experience talking to them, we need to be prompt. By we, I mean Rachel, the assistant, or whatever the name of the assistant is. It needs to be prompt, personal, persistent, and also perform. Let's look at this a bit more closely. Promptness is research and common sense, says that the more quickly you reach out to a lead, the higher the likelihood of converting them to a customer. As you can see here, even after just 3 minutes, the likelihood goes way down. So, and it's practically impossible or very, very challenging for humans to beat artificial intelligence assistants in promptness. You set a system and you run it through the information extraction loop, for example, and based on the information extraction loop, pass it to the natural language understanding system and inference system and natural language generation system, and all this, if it takes less than 3 minutes, which is the case with us, you're able to respond very promptly, whereas expecting humans to respond this promptly is more difficult. And the other decider rate that we came up with is, we discovered is personalization. It's not just enough to be quick, but the person on the other end also needs to feel like you actually care about them, and you can convey that by being highly personal in the message. That includes simple things like being from a person and not a company, or mentioning their original inquiry specifically. So for example, you see here how we customize the message based on the time, and have a personal email account and a personal greeting, and we mentioned what CRM this corresponds to, and our assistant has an email address. And in addition, because we extract a lot of intents and entities and do that at a very accurate level, we're also able to get some details in there that are not so much that are not so easy to observe, especially when the requirement is you need to respond in 3 minutes. And the third desired data is persistence. This is again something that humans fail at. After 2 or 3 attempts, we tend to not converse a lot more, but an AI assistant can be as passive or as aggressive as we want. So we typically have about 5 to 8 times of asking the same question in case we don't hear a response, and that's one way to make sure we have responses. And finally is performance. The way we measure the performance is maximizing the likelihood that an email would actually reach an intended lead or target in general, rather than end up in spam or spam or junk. So on average, 50% of business emails end up in spam folders with solicitation emails. So we commissioned an external client, and we found out that the number of emails that we send, their spam rate is far lower than the spam rate of actual humans sending similar solicitation or sales emails. So all this helped us to create this sales assistant as an example. We're also working on recruiting and several other applications, but the primary thing is it's a multi-turn conversation over multiple channels such as email, SMS, and over multiple languages. It's very good for engaging the leads and qualifying people and also following up with them. And we also have a dashboard. It's not like we just have a proof of concept and we have the technology. Over the last 10 years, this solution was deployed with thousands of customers, including Oracle, Epson, Semantics, Embroider, and CenturyLink. They trust our AI to interact with their most precious resource, their prospective customers, and they do because it works, and they have a very positive experience with this, and they feel like their sales reps are very equipped with our AI. So that's where I want to conclude. So what we have learned is how conversational AI uses natural language understanding, machine learning, natural language generation. Natural language understanding could in turn use computational linguistics, machine learning, and deep learning. To build a good AI assistant for sales, you need to make it 100% 4Ps compliant, which is it needs to be prompt, it needs to be persistent, it needs to be personalized, and the performance needs to be good. At Conversica, we applied conversational AI for multiple products ranging from sales to marketing to multiple other marketing functions and to multiple industries and verticals. So this is it from me. Thanks a lot for joining me. If you have any questions, please feel free to ask me, and do also leave me some feedback, and you can also email me or ping me any other questions you have over LinkedIn or Twitter. Let me see if there are some questions that we have time to address. Yeah, this is a relevant question. So, how far are we as a technology community or trends in terms of developing text summarization via abstraction? So, text summarization could be extractive text summarization or abstractive text summarization. So extractive text summarization is similar to Conversica's approach. We really understand everything that is mentioned in the responses with the leads, for example, or in other business scenarios with different users. So whatever a human says, we're able to understand very well. And because we're able to understand very well, we can summarize them if we could. But our application for natural language generation is responding with the next steps. And I would say Conversica could be taken as a good example for how extractive summarization or extractive natural language generation is commercially successful. And we do it so well that often humans don't realize that they're talking to an email assistant. This is a very different scenario from chatbots. For chatbots, for example, the people who are talking to chatbots already know that they're talking to chatbots, so they know what to expect and what not to expect. And B, the amount of information you send to the chatbot each time is very limited. You just pass like 3 or 4 words or one full sentence at the maximum. So the information extraction that needs to be done on that is limited. But as you see, there are a lot of chatbots out there that are doing very good work there. And the other applications that come to my mind are there are open source summarization systems such as Watson and Wolfram Alpha. They have been in existence, but in general, the better the information extraction algorithms are for that domain, the more accurate would be extractive summarization. But coming back to what the question was, they said, how far are we in terms of developing text summarization via abstraction? I'm assuming what the person is asking is really, without doing any extraction, how well is the summarization? There are several algorithms to do abstractive summarization. What they do is they try to find the most important sentences in a lengthy Wikipedia page, for example, and they just almost verbatim repeat those sentences and probably also take care of text cohesiveness to connect those sentences into one after another. As you can imagine, if you just randomly pick sentences and just stitch them together or reverse engineer them, you're going to miss a lot of information, and you're basically summarizing without completely understanding what the whole body is. So it's almost as if you're just taking a very quick glance and summarizing, as opposed to really critically understanding it and condensing a 5-page document into one paragraph. So that's the difference between extractive summarization and abstractive summarization. And for that reason, abstractive summarization is not really that accurate. We need to do most successful companies are also very good at information extraction, and with the power of information extraction, they're able to do good extractive summarization. I hope I answered that question. I think I have time for just one more question. The question is, can text mining part be used for medical research? Yeah, I mean, text mining is very relevant for medical research. I have experience doing that for 3 stakeholders. For patients or consumers like all of us, I created a question answering system based on human or community question and answer portals like Yahoo Answers. So use that as a training data to create a question answering system so that it's useful for consumers. And for scientists and researchers, I have done work to automatically rate which articles have high quality information, and I've done text summarization work to summarize the whole body of research. And for clinicians, I have summarized or extracted information from their enterprise from electronic health records. So yeah, text mining is very useful for medical research. I believe that's all the time we have for questions. Like I said, please do provide feedback, and feel free to connect over LinkedIn or Twitter and ask me any further questions. Do you have any concluding comments, Gary?
Yes, exactly. So firstly, folks, before you go, please don't hang up right away. First, thank you very much, Sid, for enlightening us. That was a great presentation. We really appreciate the insight. You had quite an audience here, so well done. Folks, before you go, a couple of things. One is Sid alluded numerous times to the research about the 4 Ps, about the best ways to apply AI, about best practices for following up on sales leads and how to apply AI to do so. That report is available on the Conversica website, conversica.com. You can click on the Resources tab and download that report for yourself or any number of other reports and useful information. Secondly, as Sid mentioned, if you look at the tabs that are available to you here on the panel, there is a panel for feedback from audience, and we would very much appreciate it if you would just take just a moment before you go and comment there, let us know what went well, how we could improve. It helps to make sure that all the webinars in the future are great. So thank you all very much for your time. Sid, once again, thank you, and folks, have a great day.
Thanks, guys. Happy holidays.